much to everyone at Toronto.js for inviting me and participating and attending. I haven't done a meetup talk in a while, but it's good to get back into it and great to share something I've been working on almost since I started at Betterment. And so tonight we're going to go on a journey to becoming a form wizard and learn how to build intuitive multi-step workflows with state machines. And so to kick started, I'm going to review some of the stuff that Jen just went over. So yeah, my name is Nick Hehr. I'm a staff software engineer on the front-end platform team at Betterment. Like she said, I used to help organize ManhattanJS, which was one of 3 or 4, depending on the time of year, JavaScript meetups in New York City. I now help organize an internal technical talk series called Better Dev at work. We actually just presented yesterday. We do that on a monthly cadence, so I get to still practice that organization skill every once in a while. I like to tinker on embedded JavaScript. Things like ECMAScript 2419 is something to look into. We can talk about later if you'd like. And I also like to cycle outdoors and climb indoors, and happy to talk about that more on Slack or later on as well. So let's see. So our journey today. So we're going to figure out what a wizard is, how we can create them or how they're usually created, how state machines can help us maybe do that better, what we can use today in tandem with that solution, and what we can do after this talk. So for many applications, as Jen mentioned before, we've had forms and charts and even wizards have been around since before the internet. And so when requesting user inputs or to create data or perform actions, it's not always as simple as a single form on a single page. Many user experiences require customers to click through multiple steps to submit all the information needed to complete that task. And so this UI pattern is often called a wizard. And this is a term dating back to the late 80s and early 90s to indicate a step-by-step guide that is designed to walk you through complex tasks. And a popular source of this vernacular, this phraseology, comes from Microsoft Publisher's Page Wizard, or even like the Connection Wizard, as you can see up here, the Windows 95 Setup Wizard. This always invokes thoughts of Gandalf to me, although others may picture other like the Connection Wizard, as I mentioned before, or even something more modern take as like TurboTax. If anyone's had to do the taxes, maybe only the folks I know in the US. So we might see something like this in terms of setting up a registration process or anything sort of onboarding within modern applications, especially if there's quite a bit of information to gather in order to get started. Filling out long forms can be incredibly tedious. And so wizards provide an experience where people can focus on individual pieces of those long forms with a sense of accomplishment as they progress forward with each step. Based on choices made through the process, the wizard can even help people skip irrelevant paths and potential confusion. I think we've all seen those sections on, again, tax forms that have a bunch of fine print that eventually lead us to ignoring it altogether. And so this is what we want to kind of avoid. We have these overwhelming long forms to view. They can be distracting because you're not sure what to concentrate on first, especially if you have a lot of tiny text to go and read. And again, like I said, tedious. Having to look at this and say, all right, time to set aside half an hour of my day to go through and complete this task. And so we want to move on to something like this. So at Betterment, we call this pattern a flow or a workflow, and we use it quite a lot. As a financial services company, there's a lot of information and complex concepts to cover, and we want to ensure our clients understand these decisions. With the usual sign-up task, we formalize creating goals, moving money, connecting external accounts, and more as flows or wizards. Given how many we've had to build and maintain, it makes sense to have some common conventions and utilities for teams to use. As you see here, as we're stepping through each part of the wizard, you can give the correct and appropriate amount of information and focus for the customer. And so how are these experiences typically built? So if you ever had to tackle this pattern in the past, you might have searched for multi-steps forms or form wizard for X, where X is a framework of your choice and for your product. I know I definitely looked around for such a solution when starting this journey at Betterment. And so naturally, I looked to the docs and examples for Formic, which is the form state manager of choice at Betterment, which works well with React. And so looking at the Formic repo, we can find examples for a multi-step wizard that creates an abstract wizard component with a wizard step child component. And this allows for a nice composition while splitting up a large form and could be reused across features as long as they all use the same layout. One notable downside of this is the lack of routing. So any sort of page reload would lose the current step within this wizard. And so just a brief overview of some common patterns we can find here is we have a wizard component, like I mentioned before. We have a bunch of steps for each of those, and they have some common actions like next and previous and any sort of submission handler, because this is one large form just broken up into several different steps. And we can see they're using, if you've never used Formic before, it's essentially just a place where all the form values can be gathered and kept track of throughout the life cycle of this feature. And we can see we're presenting individual steps based on what was chosen. And then we have a wizard step, which is kind of a pass-through component for collecting various props on this step. And it's all composed here. So we have a wizard with some initial values that are being gathered by the overall form, a submission handler. We have a wizard step, which then presents a bunch of various fields for Formic. And you see you can break up a field with a name. So we have last name here, and then another step here that gathers an email, and it even has its own validation per step. So in the same repo, we can find two examples of routed multi-step forms. One is using numbered steps, and the other is using name steps. This numbered step one we can see here is not too helpful as path names to communicate the intent of the step. As we'll see in the name steps, you have the ability to we lose the ability to customize validations and force submissions per step. So in the, this is the numbered version of the routed steps. We can see we have locations defined here. We have, again, that wizard, high-level wizard base using the component, class component API. This is kind of an older example. A page static method or property, excuse me, on the wizard base class. And again, we have those next methods, previous method or function that eventually just pushes forward in history or backwards, depending on what order you're going in. And then we have validations and submissions. And so if we look at we can still compose this in a nice manner, looking at our wizard, a wizard page instead of a wizard step, and still just listing a bunch of the various fields available under Formic. And again, all under one big Formic form, just split up into multiple different steps or pages. And then we have the named version, which breaks up our pages into individual components completely. And then instead of just having a regular submission handler, it actually links to the next page. So it knows about what's next or even what is previous within the order of this, within the order of our form. And so the greatest weakness of each of these examples is how tied they are to Formic, which ultimately makes sense because this is examples for Formic as a library. However, many approaches online will promote similar patterns, especially with routeless steps or unrouted wizards. They are all generally focused on moving sequentially, and it's not easy to see how conditional paths could be integrated. Looking at other purpose-built libraries, nothing appeared to solve all the concerns of building flows or wizards at Betterment. So that's when I set out to solve it myself. And so when beginning my journey on building it, I wanted to come up with three primary directives to help scope what I wanted to build. So the first maintains the stance that good web experiences have URLs, and aligned with our previous experience at Betterment building flows driven by Ruby on Rails. And then the second was learning from that experience building Rails-driven flows or wizards. That made it complex to maintain them because all the navigation logic was spread around to individual steps and to individual controllers, and was not easy to update or maintain over time. And the last one came from looking at our needs at Betterment and how wizards may gather information, but it's not generally required to have a form per each step because we might have to take some other action that is completely independent of an individual form. And so this was the API that I dreamed up. We wanted to be able to match what we're seeing with those formic examples where we have a high-level wizard and composing steps for each one, and then be able to render a component per each of those steps. And we can see here how we have a nice way to say each name of the step. And we're going to implement this together tonight. And we're going to use a couple of supplies along the way. So we have React context. We have the use reducer hook from React. We have the route components from React Router, which is also our routing library of choice at Betterment. And then we have a custom hook we're going to use to implement a lot of our functionality. And so if you've never used React or not familiar with React and React Router, I'll do my best to give brief descriptions of these concepts along the way. And so we're going to start with a bit of context. So this is using the create context function from React, and we're going to call it a wizard context. This is an object made up of primarily of two React components, a provider and a consumer, that allows us to share state across from the provider to anything that consumes it deep down underneath that initial provider components without having to manually pass it through as props. And so we're going to create our wizard components. Our wizard component takes a children that's generally provided by anything that accepts nested components underneath it, initial values, which looks very familiar to our initial values we saw for the formic usage. And then we're going to iterate over those children to find the names of each one. So each of them have a name prop. And so now we can just grab that and gather it into a list of steps. And we're going to set our default step to the first in that list. And we're going to use that use reducer hook, like I mentioned before. I know we were talking a little bit about Redux Toolkit earlier in the conversation tonight. And this is using a reducer function and then setting the initial state for that user reducer function to as the current step being the default step that we mentioned before as the first in the list of steps we have available. The initial values, setting the values of this value state of our reducer, and then that list of steps as well. And so use reducer returns an array with two values in it, which is the current state of our reducer, and then a function that will then trigger any updates to it. And we'll look at what that looks like in a second. And the ultimate return value of this is that wizard context provider I mentioned before with the return value of use reducer, the children steps that we have, and then also a nice handy redirect from the root of our feature over to the default step. And this just saves any sort of like knowledge or hassle for anything that is routing or linking to our wizard, having to know what the first step is in that order. And so here's our reducer. It's a function that takes in state and an action, and that state is our current state of the reducer, and that action can update the state. We have the sync action, which allows us to sync the current step in the wizard. And then we have our update values, which, as it says, updates the values within that state. And it's fairly simple overall. And then this is our step components, which is going to use a custom hook we're going to look at and coming up next. And it maps the name prop for our step component to the path on the underlying React Router route component. So that way the path in the URL will match the name of our step, making it easy to know exactly what is presented based on debugging or any sort of thing that you look in the browser. And then we're going to take the state from use wizard context and then spread it as props on the component. Now, the component itself could just call the hook itself if it wanted to. However, this saves some boilerplate and also aids with mocking or testing later on for any of these step components individually. And then here's the hook that brings it all together. So we're using the use context hook from React to consume our wizard context and then grab that value we got back from use reducer, which is going to be that current wizard state and what is commonly called a dispatch function. And that dispatch is going to send events to our reducer or actions. And so we're wrapping those various actions in these callbacks, which can be provided from the hook. And this just makes it a bit simpler and abstracts over the idea of like, oh, you have to know what the type is, and you have to know what the arguments for each of those dispatch actions are. Just allows you to call sync with a step, and that updates the current step. And then we have our update values, again, just setting values and sending that action up to our reducer. And then we're going to collect that even more under a go to step, which is going to call update values if we have values available. We can call sync with our new step and then push forward or navigate through history to that next step. And then we're going to, there we go. And then we're going to call that. We're just collecting things over and over and over again. We're going to determine the next step, looking at that list of steps from wizard state based on the current step. And if we're not on the last step, then we can go forward. And then for the previous step, if we are not on the first step, then we can go backwards. And this is just some basic logic looking at the order of steps that we've declared previously. And all of this gets returned from this hook and enabled to be used by our individual step components. And so looking back at the Dream API we had before, we can see that we have our wizard and we have our steps. And so let's look at what it looks like to create our components for each of those steps. Like I said before, we wanted to keep it form agnostic, which means that I don't need to use FormRec or any other form library. I can choose regular HTML forms integrated with React. And so we have the familiar looking props and coming from use wizard context, from go to next step, go to previous step, wizard state. And we can use that as a submission handler for our form. If anyone's never used the form data class and that's built into the browser, or even the newer object from entries method, it allows you to easily collect all of the form values from an HTML form. You don't have to do, this is not React specific, this is just generic JavaScript in the browser, and allows you to collect that into an object. And I can pass that object straight up to go to next step in order to update the internal state of the wizard with those new values. And then we can see how we can map the wizard state.values to the default value of our input. In case we go forward and come back, we can see how we saved and can reset the first name if someone wants to edit it. And then the actions look familiar to what we were seeing before with some of the FormRec examples where we have a button that can be clicked in order to go to the previous step. And then we have a submission handler to, again, trigger that form submission. And to clean up some of the boilerplates, we can follow that third directive I was mentioning before, where we can easily integrate with FormRec because it's a familiar API. So go to next step matches the same signature of the onSubmit prop for FormRec, meaning that the values just get passed straight to go to next step when the form submits. And then wizard state.values can initialize FormRec's initial values. And those get mapped directly to our field here based on first name, like we saw in the initial values before. And then we have the same actions here. And then no form is needed at all. Again, this doesn't require a form. We can just present the values themselves. So in a success step, you can just say, hey, welcome, we've gathered these values throughout the wizard. Now, this worked out really well for us, and we used this abstraction for quite a while until we ran into that same situation I mentioned before, where it's only sequential and it moves just in a linear progression. And so how do we add in conditions within this? And how do state machines help solve this problem? So for those who have not heard of state machines before, they're often called finite state automata. And it's a way of modeling logic and computation that describes the behavior of a system that can be in only one state at a given time. And the ability to transition between these states is determined by a specific set of events. Now, this may sound familiar, but let's map it directly to wizards. So a wizard is an interactive experience that can be in exactly one of a finite number of steps at a given time. The wizard can change from one step to another in response to external inputs or events, and the change from one step to another is called navigation. A wizard is defined by a list of steps, an initial step, and the conditions for each of those navigations. And we can visualize a wizard now with that modeling in mind as a state chart or a state machine. So we can see a start step that takes a next action to the about step. and then from there, next to complete, and then previous moves backwards through the chain. If anyone's ever used the stately AI visualizer from the folks at XState, we can see how we can visualize this through that graphical interface. Before I was showing you was a chart defined by text through Mermaid.js. So again, how do we control the conditional navigation? As I mentioned before, you can define the conditions in which we can navigate or transition between these various states. And so this is what it would look like to visualize it once again. We have the start step. We have a next action that hits into a decision. And that decision is based on whether or not the values contain an interest in Gandalf. We're going to move to the Gandalf step. Otherwise, we'll go to the Merlin step. And each of those define their next action as to the complete step. And we can see this visualized once again through stately AI, showing that what is called a transition guard in place. And so this always makes me think of our wizard guarding the path and making sure we have a safe journey ahead. And so we can integrate this into our wizard abstraction with a function where this is our function as a guard that takes in the current values of our wizard, the next state available to the wizard. And we're going to look at those values for an interest in Gandalf, and it'll return true if that is actually true. And we can set that as a next prop on our step component. And so next can take a list of steps as an array. And then within our guarded step, we can say, okay, what's the step we want to move to? And then when we want to move to it, and we pass in that guard function. Otherwise, we'll fall back to the next one in the list. And even without an array of steps, we can just say exactly what the next one should be, overriding the default behavior moving sequentially as they are declared. And so you can see something similar in a pattern in Cassie Williams' talk about choosing your own adventure in Next.js. She actually uses XState to create a choose your own adventure application. And it's a great talk. I highly suggest going and checking it out. So what can you do with all this information? We did go and build a basic implementation of a wizard together, but we didn't integrate the state machine part of it yet. Well, that's where RoboWizard comes in. So this is a library I've developed, taking the core idea of what we developed at Betterment into a abstract library that is framework and form agnostic. So it doesn't rely on React. It just uses that core state machine logic to develop your own integrations and powered wizards. And it uses XState finite state machine package in order to do this. And so this was originally inspired by another library called Robot, which provides a functional API for building out state machines, initially, inspiring the Robo part of RoboWizard. And I really enjoyed it, and it's still a great library. However, I wanted to embrace the larger community and tooling that XState provided, and it still gave me a minimal 1 kilobyte dependency for RoboWizard without having to rely, and we don't need all the additional power and features that the full XState library provided. However, there is a path to upgrading later on if we see that we want to add even more complex behaviors into RoboWizard. And so this is what RoboWizard, the core library, originally provides. We have a create wizard function. It accepts a list of steps and then some initial values, looking, again, very familiar to what we had within our React implementation. And then we can call start on that wizard that accepts a event listener of sorts or a callback for taking in that updated wizard whenever it does update. And we can still access our current values, the current step that we're on, and call go to next step. There's even a go to previous step method on it as well. And so it looks very familiar, and we have currently 3 official packages, RoboWizard, RoboWizard React, and RoboWizard React Router. But there are also a handful of other examples of how to integrate it with Vue, with Svelte, with Alpine.js, or even just regular plain old HTML. If you wanted to actually mostly recreate RoboWizard by hand, you could use this XState machine configuration that models the same exact thing I was doing before with that one line of create wizard. It takes in our, context here, or the values that we're gathering. We have the initial step that we're going to start on, the individual steps stated as states for this machine, and then our events or actions that we're going to perform. Next, going to about, and then updating values, so on and so forth. So let's do a quick demo if we have some time. So I created an example using the RoboWizard React Router package, which creates a nice little wizard for us as a signup, which is going to be pretty common for, I think, a lot of applications. And we can see we're pulling in RoboWizard React Router. We have a step and a wizard component. We have a list of steps that we're importing from another directory. And then we have some UI provided by Chakra UI, which is another one of my favorite open source UI libraries for React. And we have a very familiar looking API that we were building out before. We have a wizard with initial values. We have our list of steps. Instead of the component prop, we're using elements, as I'm using a newer version of React Router for this integration. And if we look at an individual step, so if we look at email here, we have, I'm using Formic, again, just showing how you can easily map back and reduce a lot of boilerplate using some of my favorite tools in React. And we're pulling in that use wizard context hook. We have a wizard, and we can pass the current values for that wizard to initial values. We can pass the go to next step here, grabbing the values and passing it through on submits, and looking very familiar to the examples we were seeing previously. And so I can fill this out real quick. And I'm hitting submit there, I just continue forward. Again, going backwards and forwards, I can hit go back. I can hit continue. I can even use the back button and go forward because this is all mapped to URLs using actual routing. If I were to build something out here and keep filling this out, I don't know why a wizard would have a phone number, but you know, modern times, got to keep up with it. We have this, again, looking and be able to focus individually on each part of the data. I can agree to these terms and then succeed at the end. And again, going backwards and forward, I'll be able to move as I want to because it's a real web app. But if I were to go back here and I don't agree to these terms, I can still continue forward. Let's change that without touching any of the steps themselves, but just affecting the wizard composition here. So I'm going to grab some pre-created, you're seeing a peek behind the magic of demos, pre-created step logic here. I'm going to override these two and add in an extra drat component that I've created as well. I'm going to grab my has agreed to terms guard function. And this is just being super explicit about that agree to terms equals true. I could just do values that agree to terms, but again, just for the sake of demo, showing how you can do that. And then I'm going to pull in my when helper from RoboWizard. And we're going to now start over. I have not touched any of the existing steps other than creating a new drat step. I haven't touched the logic in any of them. If we were to fill this out again real quick. So we're gonna keep going. I can type without looking. And I'm going to continue forward without agreeing to terms. Hey, journey ends here. Oh no, maybe we can try again. Click here and go back. And so we're able to completely control the conditions and navigation through this wizard without having to go in and change any sort of logic in the individual steps. I could go reuse these step components in another wizard somewhere else in the application. It would never have to change anything about it. It just has to know to pull in the wizard context, call go to next step, call go to previous step, gather values, and continue forward. And so let's go back to our presentation. So where do we go from here? Well, a wizard's journey is never done. So we have a lot more that we can do. What can we do to communicate about wizards better, about workflows? As we showed before, we can visualize a lot of this behavior And then we can start to iterate on a shared language that not only in engineering, but product design can all get on together, have a better way to document features that state machines provide, and allow us to have shared understanding of how we can continue to maintain and build even more complex applications. And so we're missing to help continue doing this. We can establish entry and exit steps so that way any sort of redirect on success for a wizard doesn't have to happen in the individual steps, but at the top level again. We can define final steps, which says you cannot go forward, you cannot pass. This is either like an unrecoverable error or another one of those sort of final steps for success, meaning that you can't go back and resubmit the form, you have to start over again. And then we can think about full branching flows. Think about a fork in the road that says you have to go completely in this one path that has a completely different ending from any other path along the way. And again, using that, allowing us to model this all on top of state machines and state charts, we can embrace some of the existing patterns that exist there and then just reimagine it for presenting wizards. And if this, we can also think this is all showing client-driven stuff. What about server-driven things? I mentioned Next.js before. People have talked about Remix. People have talked about all sorts of backends that we could establish server-driven side things and be able to maybe persist this state to a database and then maybe resume from a whole different client altogether, as long as we have this shared language to use to model it all out. And if this sounds interesting to you to help out, you can, there's plenty to do with RoboWizard. If you want to vet out other official integrations for your favorite JavaScript framework, if you want to help try to port it to a completely different language, that would be awesome. State machines are not a JavaScript thing. They are a generic computer thing. So we can do that in all sorts of different ways. And so thank you for joining me today. And thank you again for inviting me to come speak. You can see more of the documentation and more of the learning things at robowizard.js.org. And you can find me on Twitter at hipsterbrown. And thank you so much.